Okay, gentlemen, we're on 2.4, trends, interpolation, and extrapolation. As usual, we're going to start off with a review question just to get the math brain going here. Remember, there's two ways of solving this type of question. You can cross multiply, or you might right off the bat want to get rid of the denominator by multiplying everything by the lowest common denominator. So what I'm going to do first is write down this question one more time so we can showcase both methods. Sorry, a little chicken scratchy writing on the back of the computer. And you can go ahead and pause this if you like and work on method one and method two on your own, up to you. Otherwise, let's see what we can do here. So in the first step, I'm going to multiply everything by the lowest common denominator, each term on both sides. And I look at the largest number is 4, doesn't work with the 3. 4 times 2 is 8, doesn't work with the 3. 4 times 3 is 12, works with the 3, 2, and the 4. So we're going to multiply everything here by 12. And then we can do some cross reducing. 4 becomes a 1, 12 becomes a 3, 3 becomes a 1, 12 becomes a 4, 2 becomes a 1, 12 becomes a 6. And what you end up with is 3 times x plus 7 plus 4 equal 6x. And we're going to distribute. You get 3x plus 21 plus 4 equals 6x. We want to get the x's together. It doesn't matter which side you want to switch to. I'm going to bring the 3x over to that side. So it's going to be 6x minus 3x. Okay, which is going to become 3x. And on this side, I end up with 21 plus 4, which is 25. So I have 25 equal 3x. Divide both sides by 25, and you end up with, sorry, I apologize, divide both sides by 3, right? Divide that by 3, divide that by 3, and you end up with x equaling 25 over 3. Now, you could have written that like this. It doesn't really matter. X equal 25 over 3 or 3 equal or 25 over 3 equal x, doesn't matter. The other option would be to cross multiply. So in order to get down to a situation where you can cross multiply, you're going to need to simplify this into just a fraction, because we cross multiply when we have fraction equal fraction, but we have fraction plus fraction equal fraction. So the lowest common denominator between these two here is 12. So what I'm going to do is make that 12 plus, let's erase that there, plus that's going to become a 12 equal x over 2. I'm going to leave the right side alone. So the common denominator is 12. So 4 times 3 is 12. So I have to multiply the numerator by 3. 3 times x plus 7. And that becomes 4. Now, because they're both over 12, technically, I could just write this like this. And make all of that over 12. Now, when you could also technically cross multiply here, but it looks a little messy for some guys. So let's clean up this numerator here, and then we'll work towards cross multiplying. So distributive property, 3x plus 21 plus 4 over 12 equal x over 2. And then we're going to clean up the numerator again. The 21 plus the 4 is 25. So we have 3x plus 25 over 12 equal x over 2. And now would be a perfect time to cross multiply. So you're going to get 2 times 3x plus 25 equal 12x. Distribute, you get 6x plus 50 equal 12x. Get the x's on the same side. If I bring the 6x to the right, it's 12x minus 6x, which is just 6x. And then the 50 stays there. And this would be divide both sides by 6. You get 50 divided by 6 equal x, but that can reduce to 25 divided by 3, because you could divide 50 and 6 by 2. So that would be the most simplified. And you basically get the same answer, either method. Whatever honestly works for you. Depends on the way your brain works, I guess, and how you feel more comfortable. So here we're going to, the learning goals, sorry, I passed them there by accident. The learning goals are to recognize when data has a trend and to interpolate and extrapolate values from a given set. So because we're talking about interpolate and extrapolate, we need to come up with some definitions. This is in your textbook, but nevertheless, you can look them up or you can follow along here. To interpolate, it's within. So it starts off with the word in. So it's to estimate a value between measurements within a set of data, okay? And I'll explain more of this later. We're going to also learn about extrapolating. We're gonna do that in the questions below. To extrapolate is to estimate a value beyond the range of a set of data. I say so X is like exit, you're going out or beyond what's already given in a set of data, okay? All right, let's look at this. This table shows the time it takes a skateboarder to reach the bottom of a ramp when starting from various points along the ramp. Okay, then we have some questions below that pertain to this. And before you start graphing, you need the answers to these questions. So it says identify the independent variable and the dependent variable. I'm going to tab this down because I can. The independent variable, remember I mentioned that almost always the first one is that's given to you, the first column will be the X and the second will be the Y. And you might recall that the independent variable is the X axis, the dependent variable is the Y axis. So let's see if that makes sense here. The initial height, in this case, we'll go on the X axis and descent time on the Y. That means that the descent time, the time it takes you to descend the ramp, depends on the initial height, how far up the ramp you started. That makes common sense, right? The higher you go, the longer it's going to take you to travel or to descend. Okay, so the independent variable is the initial height in meters, and the dependent variable is the descent time, seconds. Okay, it says explain. So the amount of time to descend depends on how far up the ramp the skateboarder begins. Okay, which is the initial height, really. Okay, so obviously the higher you go, the higher you start from, the longer it's going to take you to descend. Then it says make a scatter plot and then sketch the line of best fit. Okay, we're going to learn how to do that with our GDC, not in this lesson today specifically, but we're going to learn how to do the same thing. So we probably want to come up with a title for our graph. Let's see, we can do something like skateboarder height. Let's just say height versus descent time. For skateboarders, for skateboarding. Okay, now the x-axis we said was initial height, so we're going to go ahead and label that. And this is going to be a little bit glitchy possibly, but so this is initial height in meters, and writing sideways is going to be interesting, and this is descent time in seconds. Okay, now one of the I think probably the hardest part to when you're doing this is to figure out how to label your intervals appropriately. Remember, you want to try and use up as much as you can. So on the X, I'm just looking at the range of the data here. I've got from 2 all the way to 5. So I can do something comfortably like 1, 2, 3, 4, 5. So maybe I'll just see if this works out like this. 1, skip 1, 2, skip 1, 3, skip 1, 4, skip 1, 5. That's pretty close. That's not too bad, actually. I just want to look below because we're going to be doing some interpolation and extrapolation. Let me see if these questions are going to require me to do something. So estimate the time. Look at that question. Estimate the time it would take the skateboarder to reach the bottom of the ramp from a starting height of 6 meters. So if I were to go further to 5, I could go to 6 if I wanted to here. We're going to be using that eventually, okay? But that's going to be something where we're extrapolating. So I'll write that in a different color for now. Okay, and then the descent time, looking at this data, I've got a range from 1.4 to 3.1. So, I mean, I can probably go up. Let's see if I can go up by, try and make something simple for us here. If I go to 1, 2, 3, 4, make that 1, then the next line would be 1 1/4, 1 1/2, 1 3/4, 2, 2 1/4, 2 1/2, 2 3/4, 3, and then this line here would be, that would be 3 1/4, and it goes up to 3.1. So that's good enough here. Okay, hopefully. And all right, so let's look at B, make a scatter plot. Okay, so we have to draw our dots. I'm just going to increase the width of these dots for a second. All right, and now let's look at the data. So initial height of 2 and 1.4. So I'm going to pause the video here, and I'm going to get you to graph this as well, and then we're going to I'll resume my video in a second. So let's see if I can find a way to do that. Where are you? Maybe not. There we go. All right, so I've drawn the dots. Hopefully yours looks somewhat similar. And then what we want to do is draw our line of best fit. So remember, you want an equal number of dots above and below. This is going to be difficult to do freehand, but let's try something like that. That's not too bad. What we want to do here is also look at this dot right here, a little out of place. So I didn't count that when I was trying to draw my line through the data, because this would be what we call an outlier. Okay, because it lies outside the trend. Those other dots seem to be in a nice line, or very pretty strong relationship there, a linear relationship. And this guy is just a little bit out of whack. Which coordinate is that? That is 4.5 something. So this coordinate right here is an outlier. I think we're going to get to that below. So when you're drawing your trend line, don't count that. So it says describe, make the scatter plot. We did that. Describe the relationship. Well, it's a linear relationship for sure, because we were able to draw the dots do align in a linear pattern. If it were, the dots were, instead of being in this type of pattern with that one outlier, if the dots perhaps were all over the place, then we could say there is no relationship, right? Because you can't see a pattern. And you might also have a non-linear where maybe you see the dots going something like this, and they're going non-linear. So it looks like it's more of a curve of best fit, but this one seemed to line up pretty well, obviously with a line of best fit. I'm just gonna erase some of that. Okay, so it's a linear relationship. It's also a positive correlation, because if you read the graph left to right, as the X values increase, so do the Y values. So we call that a positive relationship or positive correlation. As initial height increases, so does the descent time. Okay, so it's a linear or a positive correlation. Identify any outliers. Okay, so there's that question I was talking about. That was the coordinate 4.5, 2.2. So I'm just going to write that here. Easier to type it. Okay, so 4.5, 2.2. That's really a coordinate, so let's put that in brackets. 4.5, 2.2 is an outlier. It says, explain whether you would include any of these outliers in the data set. We're going to include it because it's part of the data. So I'm going to say yes. I would include it as it is part of the data. Right? If you start seeing too many outliers, then you're not going to really find a trend. But in this case, it's important to keep it there because you might want to explain what happened here. How is it that this skateboarder started at 4.5 meters and the descent time wasn't so good. Maybe their shoe fell off. Maybe they fell off the ramp. Maybe something happened to the skateboard. I don't know, something like that. So it's important to include that. If you're studying other things scientifically, perhaps it's important to have that information, right? It could be a vaccine, given what's going on now. And there might be the odd case that there's a negative reaction to something, or something interesting shows up in the data. So you want to keep it there and to see if it's eventually, with longer or larger studies, if there's a pattern, okay? So then it says here, estimate the time it would take the skateboarder to reach the bottom of the ramp from a starting height of 3.6 meters. So if we look at the 3.6 meter mark, I'll try and use a different color here. Let's use purple. At 3.6 meter mark, you're looking something like around this area. So if I follow this all the way up, not so easy again to do on the back of the screen. If I follow 3.6 all the way up, I'm somewhere about there. Okay, so that says it's about, if I follow that way, we're at about 2.5. Okay, so we can expect that it would take 2.5 seconds at 3.6 meter height. So estimate the time, and we're just going to say here, mine's going to show up down below, no big deal. Okay, it would take approximately 2.5 seconds for the skateboarder to reach the bottom of the ramp from a starting height of 3.6 meters. Explain how you made your estimate. I used the line of best fit, which is really your trend line, right, to estimate. Okay, and then the last question is estimate the time it would take the skateboarder to reach the bottom from a starting height of 6 meters. Okay, so let's take a look at a starting height of 6. I did that in pink, but I should probably do it in a different color now again. Let's use green. So from 6, if I'm going to estimate this time, well, this one might not work out so pretty. Let me see if this can work. So at 6, we're looking at something like this. So my trend line looks like it's going to be up there. So I wonder where that would end up if I went this way, something like that. It probably went a little bit left. If I continued that, we have 3, 3.25, maybe around 3.5, I would say it would be about 3.5 seconds. So I'll say here, it would take the skateboarder approximately 3.5 seconds. Right there, descent time to reach the bottom, of the ramp from a starting height of 6 meters. I used the line of best fit. Now I think the wording I should have used before, I'm going to use it now. In this case, line of best fit to extrapolate. Okay, that's what we did there because it's beyond the data. And then I put here to estimate, and here I'm going to say to interpolate. Okay, so remember, to interpolate is within the set of data. So let me explain that here. Within the set of data, when it asked us for what would happen at 3.6 seconds, that's somewhere in between some dots or data given. But when it asked us what happens at 6 meters, that's outside the data given, right? So if you even look at your table of values, 3.6 initial meter height is somewhere between these two values here. So it's somewhere between our data that's given, but 6 meters, because it ends at 5, the 6 meters is now beyond the set of data. So that would be extrapolation. It's outside the data. Okay, so hopefully that helps. All right, and that's it for this video, guys. See you next one.